Okay, so using congruent triangles. So this is going to be the stuff that I was talking about with CPCTC, right? So let's just jump right up to an example. So what about this guy here? So if we've want to okay, what about this one? Let's look at this case. Suppose that this is the stuff that we're given. Okay? We're given with some congruent sides, and that's it. We're told that side PQ is congruent to side RQ, side PS is congruent to side RS, and we want to show somehow that angle PQS, so if I were to draw that in, it would just look like this, right? We want to show that that angle is congruent to that angle somehow. That's our goal of our proof. Okay? What do you think? Suggestions? How could we go about doing it? And, well, stare at it for a second. See if you come up with. What do you think? Okay, good. Now, and what Lenny's getting at is, if we can show that the triangles are congruent first, then because those are corresponding parts of those triangles, we can show that those angles are congruent by CPCTC. There is no fancy theorem or postulate that somehow is going to allow us to just directly show that those angles are congruent. It just isn't, right? But look at these triangles here. If I look at the triangle on the left and the triangle on the right, I've got two of those sides are already given to me as being congruent. Now, how could I get the third side congruent? It's a shared side, right? Good, so by reflexive property. So I've got this side right here, QS is congruent to itself by the reflexive property. And so now I've got these two separate triangles, each of which, in each of these triangles, all three sides of the left triangle are congruent to all three sides of the right triangle. And so I know that triangle QPS is congruent to triangle QRS, don't I? By side, 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 right? So let's write that. Triangle QPS is congruent to triangle QRS by side, side, side. And so then, if I want to show that that angle PQS is congruent to angle RQS, well, look at that. PQS is going to correspond to RQS over here, isn't it? And we can see that they do. If we match up the corresponding parts, you can see that those sides go together, those sides go together, these sides go together. So those angles go together, don't they? Right? And so then we know for sure that that angle and that angle, they have to be congruent to each other. And what's our reason? We already know that the triangles are congruent. So we could say this is true by what? What's our reason? CPCTC. Corresponding parts of congruent triangles. Those are congruent, right? These triangles are congruent. So corresponding parts, in this case corresponding angles, but corresponding parts of congruent triangles are congruent, because that's what congruent means, right? Congruent triangles means that all the corresponding parts are congruent, all 6 of them, including the 2 that we're interested in. Does that make sense? So that's our strategy. Our strategy is to actually, even though the question is not asking us to prove that the triangles are congruent, we need to. We're going to show that the triangles are congruent, and then because they're congruent, those corresponding parts just come with the package by CPCTC. Okay? So here's kind of the way the book describes it. I mean, that's just what we just did. Right? We're going to show the triangles are congruent by SSS, and then we can use CPCTC to show that the corresponding angles are congruent. Okay? All right, let's try another one. Okay, what about this guy? This third data set. Given that side AB is parallel to side CD, so let's write that in. How about it? So that's parallel to that, and BC is parallel to AD. Prove that AB is congruent to CD. Okay, now you see here that there's probably no way we can do that directly, but if I could show that the triangles were congruent, then I could show that those sides are corresponding sides of the two triangles, and so they would have to be congruent. So it's kind of a roundabout way, but if we could prove that the triangles are congruent, then we get all those other corresponding parts congruent for free. Now, how could we do that? We got to get 3 parts of the triangles, right? You know, SSS, SAS, something like that. We got to get 3, either some combination of sides and angles. We need 3 of them. Is there anything we get from 3 of them? What do you think? Okay, good. We get 2 parallel lines and a transversal. Okay, good. So let's extend. How about if we extend these lines first? So I've got the 2 blue parallel lines are cut by this transversal, right? And if parallel lines are cut by transversals, there's a lot of stuff that's congruent. Well, what can we say about this angle here and this angle here? What kind of angles are those? If I call that angle 1 and that angle 2, what's the relationship there? What are they? Alternate interiors, right? Alternate because they're on opposite sides of the transversal, and they're interior, they're inside the blue lines, right? So then we know by alternate interior angles that angle and that angle are congruent, right? Okay. We could do the same thing if we extend the other lines. What if I extend this one and this one? And there's my transversal. I could also say those 2 are alternate interiors, couldn't I? Right? Does that make sense? And so now that's pretty good. We got 2 pairs of congruent angles using that parallel line transversal relationship that we've done so much with, right? All right, so let's see where we are then. So we said that's parallel, and we got this much. Okay. So there's 2. We need 1 more piece somehow. To get those triangles congruent, we got to get something else. What else do we know? That's true. That's true. By the third angle theorem, we'd also know that the third angles are congruent. But angle is not one of our congruence relationships, is it? I got to get a side in there somehow. Oh, okay, good. They share a side, don't they? They share side BD. So by the reflexive property, side BD is congruent to side BD. And now we got it, don't we? Because if I pull those triangles apart, look what we've got. If I focus just on the bottom one, I've got 2 angles in the included side of one triangle are congruent to, if I look at the top one, 2 angles in the included side of the other triangle. So what's my reason then for saying those triangles have to be congruent? Angle side angle, right? And remember, if an ant's walking around the outside, he's going to hit an angle and a side and then an angle as he walks around those triangles. So that's the order, ASA. So by ASA, the triangles are congruent, right? If the triangles are congruent, then I could say that AB and CD, well, and let's make that statement. I guess let's make the triangle congruent statement first. Triangle ABC is congruent to what triangle over here? I got to line up the corresponding angles, don't I? So what angle goes with A? C, okay? And then I went, now we gotta count the loops. I went from no loops to one loop to two loops, right? I gotta do the same thing over here. No loops to one loop, so that's gonna be C, D, B. That make sense? Okay. So now prove that side AB is congruent to side CD. Easy. Look, AB and CD are corresponding sides of the two triangles. So by CP, CTC, they're congruent. Right? Now, if we wanted to look at this one, I think this one actually is really two column proof. Well, it's not, but let's write it out now. So if we wanted to write this one out, we could just set up our two column proof where we've got our statements and our reasons, right? And then we had some stuff that was given to us. So we had AB is parallel to CD and BC is parallel to AD. What's our reason for that? Given, right? That's stuff that's given to us. So that's given. Okay, what about where do we go from there? Well, you told me that if we extended those parallel lines, right, we were able to get these angles congruent, like alternate interior angles, right? Because those lines are parallel and those lines are parallel, that told us that angle, how do I say that angle up there, that top one? So DBC or CBD, right? Make sense? I gotta say it that way, because if I say angle B could mean lots of things. Like angle CBE means just that angle right there, right? So angle CBD is congruent to angle, how do I say that one down there? How do I say this guy? Say it again. BDA or ADB, yeah, either way. And then also, this guy right here, so that's angle what? ABE is congruent to CDB, angle CDB. And what's my reason? Yeah, alternate interior angles, right? So that gave us two congruent parts, and then you guys told me I should do that, right? So line 3 was just side BD is congruent to side BD. And what's always the reason for that? They share a part. Reflexive property. Okay. And then what did we say? We said the triangles can be. Okay. So step 4, we said triangle ABD was congruent to triangle CDB by ASA, and then finally, last step. And as you do more and more of these, what you're going to see is that okay, well, anyway, you'll notice that these steps always go in this order. You're gonna have some triangle congruence, and then the very next step is CPCTC. Right? So the last thing is what we're trying to prove. That was AB. So the very last step you can see down here. Side AB is congruent to side CD, and that was what we were trying to do. That was the whole point of this. And the reason was CPCTC. Okay? There's our proof. Okay. Questions on that? What about this one? Deal. I want you to just see if you can set up a strategy. Can you see how this could work? Given that A is the midpoint, notice kind of got graphed somehow. That's supposed to be an M. That's an A. That's a T. That's an R. So A is the midpoint of MT, and A is the midpoint of SR. Can we somehow prove? We want to prove here is that MS is parallel to TR. Now, how could we prove, if we kind of think about this logically, how do we prove lines are parallel? Going back to chapter 3. How do we prove lines are parallel? Say it again. Well, same slope if we were doing, yeah, that's true. If we were doing a different kind of problem, like on an XY grid or something, sure. But for stuff like this, how are we able to show it? I could extend the lines. So here's line MS, right? And here's line TR. But how do I show those are congruent? This has to do with transversal stuff, doesn't it? Right, so I could say now, what if, for example, I were to extend this transversal? So we've got this line like so. Is there, if I could show an angle congruence on it, like for example, what are some angles? If I could show some angles to be congruent, how could I conclude from that the lines are parallel? What are some angles that would work? See what I'm saying? Maybe I didn't say that. In order to show that these lines are parallel, we have a bunch of going back to chapter 3, we have a bunch of converse statements. They say things like, if this is congruent to this, then the lines are parallel. Or if these lines are supplementary, then the lines are parallel. What are some examples of that might be helpful here? Say it again. Yeah. If alternate interior angles are congruent, then the lines are parallel. We call that the alternate interior angles converse, right? Well, wouldn't angles M and T be alternate interiors here? Right? Does that make sense? Does everybody see that relationship? Because you got to see that. If you can't see that, I mean, that's real important. They're on opposite sides of this transversal. Let me make this transversal pink so we can see this. Opposite sides, but inside the two parallel lines. So if we could show that those lines were, or that those angles were congruent, then by the alternate interior angles converse, we could demonstrate, or we could show that MS and TR are parallel, right? That's our goal. So our goal is somehow we got to get those angles congruent to each other. Well, how could we do that? Right? So that's our goal. We got to get those angles congruent. Now, if we start from scratch, how could we get there? Given this stuff, what's it mean that A is the midpoint of MT and SR? How does that help us? What's a midpoint? Cuts it in half, right? It cuts each of those segments into two congruent pieces, right? So by the definition of midpoint, because that's a midpoint, don't we know that, right? And don't we know that? two angles right here, angle MAS and angle RAT, those angles are congruent because of vertical angles. And now what is that? How does that help us out? What do we now know about those two triangles? They're congruent, right? Those angles are congruent by what? Are those triangles, sorry. This triangle over here is congruent to this triangle over here by what? SAS. Side, angle, side, right? Two sides and the included angle of the left triangle are congruent to two sides and the included angle of the right triangle, right? And so now we know that triangle, if I call this one MAS, what do I have to call this one? M goes with what? Does it go with R? Nah, it goes with T, doesn't it? Right? Because look, M is the one that's between one slash and no slashes on the sides. Everybody see that? So that's T. T has one slash on one side and no slashes on the other side. So the M and the T go together. Does that make sense what I'm saying that? Now you gotta really pay attention to this. Okay, what about the S? S has got the angle S on one side has two slashes, on the other side has no slashes. So what's that go with over there? R. Okay, so S goes with R and A must go with A. Right? Everybody see that? Okay, so then aren't angles M and T, those are corresponding angles, right? Right? So now I can say those are congruent. By what reason? CPCTC, exactly. Once I show that the triangles are congruent, then I know that I can say those corresponding parts are congruent by that reason, CPCTC. It's too much to write. Corresponding parts and congruent triangles, way too much to write. So we just abbreviate it, CPCTC. There you go. Right? And then once I know, now we're there. CPCTC. There you go. Okay. So anyway, so now, and that's what we said we needed to show, right? If we could show that those angles were congruent, then we can say by corresponding, or excuse me, by alternate interior angles converse, now we know those lines have to be parallel. Yeah.
Okay, this is a long topic, but when's spring break?
End of March. I don't know the exact date.
So like end of March.
End of March, yeah. Okay. Okay, so here it is. Let's just organize this. So here it is. It's two-column proof. Here's our given stuff, right? We said that we could, if we mark this off. Okay, remember we said by definition of midpoint, that stuff was true, right? So that's just saying MA is congruent to TA and SA is congruent to RA, right? So that's definition of midpoint. Okay, right? And then we said that these angles in here were congruent because they're vertical angles, right? So step 3 is just going to be vertical angles. All we have to say is vertical angles, right? Step 4 then, we said, okay, now we got enough information to show that the whole left triangle is congruent to the whole right triangle. We have to be careful about that congruent statement. M lined up with T, A with A, and S with R, right? And we said that was side angle side. Okay, so there's SAS, that's all we need, SAS. Angle M is then congruent to angle T. Once we know the triangles are congruent, that's just CPCTC. I hope they write it that way, do they? No, but we would just see, they write just CPCTC, much easier, right? CPCTC. And then finally, now we can say, okay, well, those are alternate interior angles. So if alternate interior angles are congruent, then the lines are parallel, corresponding, or excuse me, alternate interior angles converse. Okay? Okay, one more. One more of these. I know there's a lot. These proofs are kind of long, but you gotta battle these things a little bit. I'm gonna make you do some of these on the test. So you gotta know how to do these. Okay, everybody with me?
Got it.
All right. So what about this one? Now let's just see if we can talk our way through this. See if we can get a strategy. Given that angles 1 and 2 are congruent, okay, and angles 3 and 4 are congruent, that's it. We want to somehow show that triangle BCE, that little guy on the bottom, just right there, okay, is congruent to triangle DCE. Okay. I could let you struggle with this for a little while. But what's the only other piece of that we could get? They share a side, don't they? They share side CE, but that's it. There's nothing else we could get. And so we'd be stuck. If we just left it at that, we'd be stuck. We got to do something different, though. Now, we do have this other information that doesn't seem to relate at first. Angles 3 and 4 are congruent. They're not even parts of these little triangles, right? But they are parts of some bigger triangles. What if I take this whole triangle on the top? So I've got, let's say on the top I've got triangle CDA right there. Okay, and on the bottom, in red, how about, we've got triangle CAB. Okay, what if we do that? Now look at this. Look what we've got here. We've got that angle's congruent to that angle. That angle's congruent to that angle. What else do they share? They share a side, right? They share side CA. Right? So by angle, side, angle, the green triangle and the red triangle are congruent, right? Aha! And if the green triangle and the red triangle are congruent, then now we can get that third piece that we didn't have before, right? Remember, all we could get before when we focused on the little triangles was CE congruent to itself in that angle, but now we could say, aha, CD and CB, because those are corresponding parts of the green and the red triangles, which we now know are congruent by CPCTC, we can, that's a mouthful, we can say those two are congruent, right? Does that make sense? Okay? And that gives us all we need. Now, I've got those angles, that shared side, those two pieces, and so how are the two little triangles congruent? By what? Side angle side. Okay? See how that works? Wait, there it is. So AC is congruent to itself, reflexive property. ABC is congruent to ADC. The big top one and the big bottom one are congruent by angle side angle. BC is congruent to DC by CPCTC. CE is congruent to itself. And so we can say the little guys are congruent by side angle side. Okay? Okay, you know, I'm thinking, that's all I'm going to do. I don't think I can go through that. That seems like that's plenty. Okay, let me take roll, and then we're about done.